In this third and last part of the control flow tutorial, we will be discussing control transfer statements in Swift. Control transfer statements are used to change the order of execution of the Swift code. There are 5 different control transfer statements in Swift. They are continue, break, fall through, return, and throw. In this tutorial, we will be looking at the first 3 of these. With continue, we can interrupt the execution of the current iteration of a loop, and following the interruption, we go to the next iteration of the loop. So in other words, with continue, we do not terminate the execution of the loop completely. We just terminate the execution of the current iteration of the loop. Here is an example where we have a for loop, and the loop temporary parameter count, C and T, takes values from X, which is a value range going from 2 to 4. So as long as the counter value is not equal to 3, the body of this loop is completely executed, and we reach to the end line of code here, and this message is printed. But if counter is equal to 3, we execute these 2 lines of code and we print this message, which indicates interruption in the code execution. And as soon as we reach continue here, we terminate the execution of this iteration and go to the following loop iteration, which corresponds to the value of count equal to 4. So the outcome of the execution of this entire for loop will be this. When count is equal to 2, the if statement is ignored here, and we print this message. When count is equal to 3, the interruption message is printed, and continue kicks in and interrupts the current iteration of the loop. And we immediately are taken to the next iteration of the loop, where count is equal to 4, and as a result of that, this message is printed. The next control transfer statement that we look at is break. Unlike continue, which is used to generate interruptions in the current iteration of a loop, break stops execution of a loop or a conditional statement completely and transfers control to the line immediately after the loop or the conditional statement. Here's an example of the usage of break when applied to a for in loop. The loop temporary parameter counts from 2 to 4. If count is equal to 3, this body of code is executed, which includes break. And once break is encountered, we jump completely out of the for in loop to the line immediately after the for in loop. So let's have a look at what happens when we run this thing in detail. When x is equal to 2, the if statement is not activated, and this message is printed. This is what we see down here. For the case where count becomes equal to 3, meaning the next iteration of the loop, the if statement is activated, this message is printed, which is shown here, and then as soon as we encounter break, we jump out of the loop completely to this line of code, and the result is shown here. A second example here shows how break can be used in a conditional statement, in this case switch. We have two variables defined up here, x and y. Switch parameter is x, and there are different cases defined here. First case says that if x is equal to 2, we print this message which indicates there's no interruption. If case is equal to 3 and if y is equal to 10, this if statement is run, which includes a break. And if y is not equal to 10, this line of code is executed, which again indicates there is no interruption. And the default case also indicates no interruption. So in this particular example, x is equal to 3, so case 3 is the one which is selected, and y is equal to 10, so if statement is activated. So as a result, we are within this if statement code where this line is printed, and this is what we see here. Then we encounter break. This time we jump completely out of the switch without executing this line of code, and we end up executing this line of code which is completely outside the switch statement, and as a result this line is printed. Fallthrough is the last control transfer statement that we discuss in this tutorial. Fallthrough is used in switch statements, and when fallthrough is present in a particular case of a switch statement, we move from that case into the case immediately following the current case, without even checking the value of the new case against the switch parameter. Here is an example where we have two variables, x and y. Y is a string and x is an integer, and we have a switch statement with a case including fallthrough. So if the value of x is equal to 2, y, which is initialized to be an empty string, will be set to this string which says 2 followed by a single space, and then we encounter fallthrough. What fallthrough does here is it sort of takes us directly into the following case, which is default in this example, and y will be appended by 3 dots. Now let's have a look at the example and see what this does. X is equal to 2. As a result, case 2 is indeed selected. Y will become equal to 2 followed by the space. Then as a result of fallthrough, we go into the default case where y is appended by 3 dots. And at the end of this switch case, we print the value of y, and in this case y is equal to 2 space followed by 3 dots. So we can see that because we use fallthrough, we have actually executed 2 sets of codes. One was in this case and the second one was in the default case. Now let's have a look at the same example, but this time we change x to 1. So that means that the selected case is this case, which does not include fallthrough. It just sets y to the string 1, and when we come out and y is printed, we end up with 1. So in this case we just have a simple switch case when it's completely executed, and then we jump out of the switch as we did before. When we're dealing with nested loops, nested conditional statements, or combinations of loops and conditional statements, and at the same time we would like to use control transfer statements such as break or continue, Swift will provide us with the possibility of labeling the loops or conditional statements to indicate that which one of the loops or conditional statements break and continue should affect. Here's a simple example when we have a for-in loop, and within that loop we have a while loop. The while loop is labeled by this thing called label 1. Label could be anything. I've chosen label 1 here, and the syntax is we enter the label before the loop statement or before the conditional statement, and we separate the two by a colon. So in this example we start with a variable x which is initialized to 0, and then our for-in loop repeats the code within its body twice. So in the first round we print the value of y, which is the temporary parameter of for-in loop, and then we enter the while loop. The while loop is expected to repeat 5 times. So we enter the while loop, we compare the value of x, which is the loop parameter, with 1. If it is not equal to 1, we just continue with the rest of the code within the body of the while loop, and we print the value of x, and following that we increment the value of x by 1. Then we repeat this for all the number of times that the while loop is supposed to be repeated. If x is equal to 1, what happens is that we set x to 0, and then we encounter a break. A break here is indicating that it's going to be applied to the statement whose label is label 1. So in that case we are talking about this while loop statement. So as a result of this we break out of the while loop which has label 1. So we come out of the while loop, but then we don't get out of the for-in loop, because break only in this case applies to the while loop. So in the second round of the run of for-in loop, y will become to 2, we print it, and we again enter the while loop. So for the first time, because x is equal to 0, the if statement is not run, and we print the value of x, we increment x, and then we continue with our while loop. In the second run of the while loop, x is now equal to 1, the if statement is activated, and for the second time the break causes a break out of the while loop, because again label 1 indicates that while loop is the one that the break should be applied to. So we get out of the while loop for the second time, and then for in loop no longer is needed because y has reached its maximum value, which is 2. Then we exit the loop. So these are the results. For the first case, y is first printed, which is equal to 1. Then x is printed equal to 0, but as soon as we reach the value of x which is equal to 1, we break out of the while loop. So we don't do the rest of x values, which are supposed to be 1, 2, 3, 4, and then we enter the second run of our for-in loop where y becomes equal to 2, and similarly x is only printed once when x is equal to 0, because the second time that we enter the while loop, again we have the break which forces us out of the while loop as soon as x becomes equal to 1. In Swift, we can use this thing called a guard statement. In effect, a guard statement is like a barrier between where it's inserted and the rest of the code that follows it. The guard statement contains a Boolean condition, which if it is true, the guard statement allows the continuation of the rest of the code which comes after it. If it is not true, the guard statement always includes an else clause similar to the if-else statements that we've seen before, and that else clause will contain the alternative code which should be run instead of the code which appears after the guard statement. Similar to optional binding, where we dealt with optionals and we assigned the unwrapped value of optional to a temporary variable and used that within the structure that the optional binding was used. We could declare a variable and assign the unwrapped value of an optional to that variable. That variable can be used within the rest of the code which come after the guard statement. So generally the way the guard statement works is that if the condition of the guard statement is true, the code after the guard statement is executed, and if it is not true, then the code within the else clause is executed. One very important thing is that the else clause should have a control transfer statement in it, something like break or continue or return in terms of functions, to ensure that we break out of the rest of the code which follows the guard statement. So the guard statement cannot be used anywhere. It can be only used within the structures where control transfer statements can be used. Here's the syntax, general syntax of a guard statement. We have the keyword guard followed by a Boolean value, and then we have else followed by opening and closing braces, and within the braces we have the else clause. One way to look at this is that whatever appears within the braces would be the body of the else clause, and whatever appears after the guard statement would be the body of the guard statement. So if the Boolean value is true, the guard statement indicates that we can run the rest of the code. So the guard allows us to go through the rest of the code, and if the Boolean value is not true, the guard will prevent us to execute the rest of the code, but then it directs us to execute the else clause. And within the else clause, as I mentioned earlier, we are going to need a control transfer statement. If we wish to declare and assign parameters using the guard statement, we can follow a similar structure as we did with optional binding. So we have the keyword guard followed by the keyword letter var, and then we have the optional binding equation where x is a parameter which is assigned the unwrapped value of optional y if the value is non-nil. If y is nil, then this condition will be false. As a result, the guard statement will prevent us from running the rest of the code, and instead the code within the our else clause will be run. One more thing to remember is that the value of x, which is declared and assigned here, can be used in the rest of the code following the guard statement. Remember, as I mentioned before, that the code after the guard statement can be considered as being the body of the code for the guard statement itself. Let's have a look at a few guard statement examples. To start with, we have an example which follows the second syntax that we discussed earlier. Here we have a variable q which is of type optional int, and it's assigned a value of 5. We have a guard statement which is inserted within a for in loop. As I mentioned earlier, because we're using this control transfer statements, things like break, continue, and so forth, the guard statement should be placed within structures which accept the presence of such statements. So in this case, we are dealing with this for in loop. The guard statement is placed within the for in loop, and this guard statement is only applicable within this for in loop, not outside of this. So what the guard statement here does, it guards whatever code appears beneath the guard statement, and it only allows its execution if the guard statement condition is true. If the condition is false, then we will have to execute the code within the else clause. In this case, these are the 2 lines of code, including our break. So the way this thing works is like this, that once we enter the loop, for each entry of the loop, we first check whether q contains a non-nil value. If it contains a non-nil value, this condition will be true, and also the unwrapped value of q will be assigned to this parameter called num here. When the condition is true, the guard statement allows us to execute the code beneath it, which falls within the boundaries of our for in loop structure. Now, if q is equal to nil, it doesn't contain a non-nil value, this condition will be false. As a result, the guard statement here stops us from executing the code beneath it, and we will have to run the code within the else clause. Also remember that the parameter here, which is declared by the guard statement, will remain valid for the code which is underneath the guard statement and falls within the for in loop. But as I mentioned earlier, we can consider this to be the body of the guard statement, and we can assume that num is a temporary variable which is only valid within the body of the guard statement, which is effectively the code which falls underneath it. The availability of this parameter is only within the for in loop. Outside the for in loop, that parameter is no longer available, and that is why this parameter could be considered as being a temporary parameter. So when we run this code for the for the values of x running from 1 to 3, this will be the result we get. We start with q to be equal to 5. So we enter the loop. Q contains a non-nil value, so that value is assigned to num, which is equal to 5. And then we go beneath the guard statement, print that number, which is 5. Because Q is an optional, we have to unwrap it in order to update it. So this is what we're doing. We update Q by incremented by 1. So new value of Q will be equal to 6. We go round the loop one more time. Q is still equal to a non-nil value. So num is again assigned, and the code beneath the guard statement executed, and we repeat this. So the output of this will be 6 and 5, 6 and 7. An alternative to this would be when Q is not assigned to a value. In other words, the value of Q is nil. So when we enter the loop, Q will be equal to nil. This condition will be false, and the guard statement is going to stop us to access the code beneath it. But then instead we are directed to run the code within the else clause. As a result, we print this message, and then we break out of the for in loop, and this would be the outcome of that operation. Finally, here is an example following the first syntax that we discussed earlier. Here we are not declaring a parameter using the guard statement. All we do is we check this guard statement condition and see whether this is true. If it is true, the code below the guard statement will be executed. Otherwise, the code inside the else clause will be executed. In this case, we start with x equal to 1. So the first time around that we go inside the loop, the guard statement, the condition of the guard statement is true. So we execute this statement. So as a result, we get x equal to 1. The second time around, this condition is no longer true. So we run the statements within the else clause. So we print this statement, x is not equal to 1. Then we encounter a continue. That continue causes us to interrupt the current iteration of the for loop. So we do not print this message. Instead, we go and start the next iteration of the loop where x is equal to 3. Again, when x is equal to 3, we will have to execute the else clause. We print this message, and continue will cause us to jump over this line of code, but because the for in loop has reached the maximum number of iterations that it was designed to do, we get out of the loop completely. With this, we end our tutorial on Swift's control flow.